speed control of induction motor. So there are different types of methods used for the speed control of induction motor. First, by change or by varying in the stator voltage applied to the motor. Second, to change the frequency of this induction motor. And third, speed control of slip ring induction type motors by using chopper circuit. So first, the speed control of induction motor by varying the stator voltage. Now the stator winding, here we are using three-phase type induction motor. So each stator, it is connected in delta connection. So there are two possibilities. In one case, the SCRs are connected in the line, or second, the SCR connected in the phase, or you can say in the individual winding. So first, this is the diagram for the speed control of induction motors by varying stator voltage with the help of SCR. So in this case, two SCRs are connected in anti-parallel in each and every phase. So here S1, S2, S3, S4, S5, S6 are the SCRs are used to supply the stator voltage of this induction motor. So here when S1, S2 and S1, S3 and S5s are turned on, the current passing through the stator winding in one direction. Now when S2, S4 and S6 are fired, that time current passing through this in winding of the stator in another direction or the reverse direction. So by changing the value of the firing angle of this SCR, the speed of the motor also varies. So we are increasing the firing angle of SCR, which will reduce the speed of the induction motor. So here the most important thing, the SCRs are connected in the line. So the rating of this SCR must be require higher capacity, because your line current is √3 times greater than phase current. So there is a main disadvantage. Now here this is the second diagram in which the SCRs are connected in the phase. So it will reduce the capacity of this SCR. So here also S1, S2, S3, S4, S5, S6 are the 6 resistors. Now and another most important thing, the phase current is, already I told you, the phase current is less than √3 times of line current, which will reduce the current capacity. So there are two types of systems are used. Now this type of method is used for less and medium capacity of the motor. So let we see the advantages and disadvantages of this method. First, advantages. This method is very simple. Second, it is very reliable. And third, wide range of speed control is available. Third, disadvantages. The waveform becomes non-sinusoidal. So hence the harmonic is produced, which increase in the heating in the windings. Second, the motor current increases when speed is decreased. Now this is also increase in the heating. This is especially important when the torque is very proportional to the square of the speed. So now these are the disadvantages of this speed control of induction motor by using SCR. Control of three-phase induction motor by varying frequency. As we noted, the synchronous speed of induction motor is directly is equal to 120 F by P, where F is the supply frequency and P is the number of poles in the induction motor. So we can say that the synchronous speed of induction motor is directly proportional to supply frequency and inversely proportional to the number of poles. Now if we keep number of pole P is constant, then we can say that the synchronous speed of induction motor Ns is directly proportional to the frequency. So if we change the supply frequency of this induction motor, it will change the synchronous speed of this induction motor. As a result, the speed of motor also changes. Now we know that the torque produced by this motor T is directly proportional to phi, and the induction motor is specially designed for a particular flux density. So it is most important, and this the frequency can be changed with the help of 6-phase inverter. Now the E is directly proportional to phi into F. Now if we want to keep flux constant, then E by F ratio must be kept constant. So if we change the frequency, supply frequency, the output voltage of inverter, it is also changed, which remains E by F ratio make constant. So it is most important thing. Here S1 to S6 diode, 3-phase diode are used to convert AC supply into DC supply. Then the output of this converter is given to the filter circuit, which consists of inductor L and capacitor C, which is used to remove AC components still present in the DC signals. So we can say that after filter we will get smooth DC, and this smooth DC is given to the inverter circuit. The output of this inverter circuit given to the stator winding of this induction motor. So now the control unit has frequency control with reference signals, and the output signal of this frequency control system is given to the phase gate control, which control the firing angle of this SCR present in the converter. So this is the basic diagram. Now the output of this inverter is a six-step type output per one cycle. Next, the advantages of this method. First, wide range of speed control can be achieved. Second, to keep motor speed higher than the synchronous speed. Now, disadvantage, this method is costly. And second, increase in the supply current. Speed control of slip ring induction motor by using chopper circuit. As we know that the speed of this slip ring induction motor can be varying by adding variable resistance in the rotor circuit. So here this is the basic circuit of this speed control of induction motor by using chopper circuit. So here resistance R1 and R2 are inserted in the rotor circuit through the slip ring, and these thyristor are used as a rectifier, and this SCR is used as a chopper, or you can say that high speed switch. So here the speed of this induction motor is changing by changing the value of variable resistance inserted in the rotor circuit of the slip ring induction type motor. So now when the resistance R1 is present when this SCR is on, so now this resistance R2 is short circuited when the SCR becomes on. So only R1 resistance is present in the rotor circuit of the induction motor. Accordingly its speed is changes. Now when the thyristor is in off condition, that time the effective resistance becomes R is equal to R1 plus R2. So R1 plus R2 effective resistance is inserted in the rotor circuit of this slip ring type induction motor, which will change the speed of the motor. So here you can say that when SCR1 on, R1 is present, and when SCR is in off condition, that time R1 plus R2 resistance are inserted in the rotor circuit of the slip ring induction motor. So we can write effective resistance R is equal to R1 T on plus R1 plus R2 into T off whole divided by T on plus T off. So the speed of this induction motor is depends on the inserted resistance and the on-off period of this chopper. So if we change the duty cycle, it will change the speed of this slip ring induction type motor. So there are some advantages. First, smooth speed control is can be achieved. Its response is very high, and it also improve the power factor of this induction motor. It is most important advantages of this method. Now there are some disadvantages, because here we are using resistance in the rotor circuit. So when current passing through this inductor, there is some power loss occurs in the resistance, which will decrease the efficiency of this motor. Second, the speed control can be achieved less than its normal speed. It is also most important disadvantage of this method.